All right, so this is a review of the lab that we did the Tuesday before Thanksgiving for those people who weren't able to be here or didn't come, whatever the case may be. So take a look at the board over here. We'll pan over to that. You can see the data table. This is in the lab handout that you have in Google Classroom called Halogen Activities. So you need to open that up if you're just doing this at home. All right, so I have here 3 test tubes. Notice that there are 3 boxes on the top row up there that are empty. Point to the top row over there, my lovely assistant. Okay, so pointing to the top row right there. And here they are. So I have here a solution of sodium fluoride with hexane on top, and I have already added some chlorine to it. The chlorine came from this bottle here. Notice the color is kind of a light green color, which is characteristic of chlorine, or yellow-green. You're not going to be able to see that very well here because this is already kind of pale, and when you lower the volume as much as we have here, it's going to be pale. Although, I don't know if you can see it through the video screen or not, but it looks a little bit to me standing here, a little bit like it's a slightly more green color up here than it is down here. Notice there are 2 layers. The layers come because I'm using hexane as a solvent. This is hexane being out of this bottle. So hexane is a solvent, and the halogens, chlorine, fluorine, bromine, iodine would all dissolve in the hexane, I mean. All right, so that one has chlorine at the top. The top we'll say is green, light green. So right with your finger up there, green in the chlorine box. Not there to the left.
No,
right
I'm seeing who's on green.
Okay, there you go. Now the next box up there had bromine on the top. So I have the same setup here. I've already mixed them. All I have to do is shake them up so we can kind of go quickly for our little video. And as I shake it, you can see that the top becomes what color? Orange. Okay, so we have orange at the top. And then the third one, I have iodine added. Same setup, shake it up. And what color does the top become?
Purple.
Purple. All right, so we write purple up there. Okay, that was the first row. Second row, we have NaCl. This time I only have 2 test tubes because there's only 2 boxes that are empty up there. So in the first test tube I added bromine. Shake it up. Notice I'm holding this test tube really tight at the neck to get really good agitation. And there you have bromine at the top. See, that's orange at the top, light yellow orange. Okay. It's supposed to be kind of similar to this color, but this is more concentrated, so it shows up better. Okay. And now the last one is over there is iodine column with NaCl. Shake it up, and what color is that top layer?
Purple.
It's purple. Right, now I have NaBr and chlorine. I'm going to add just a little bit more chlorine to this out of my stock bottle. A little more concentrated, see if it makes a difference. A little more chlorine. Put the lid back on that. This smells like a swimming pool on steroids. I shake it up. I added the chlorine in the NaBr box. What color is the top layer now?
Yellow,
Yellow.
orange.
I would
Yellow-orange.
say it's a yellow-orange,
Oh,
probably
yellow.
more. Actually, no, you look at it, it gets more orange as time goes by.
Yellow.
Orange. It's not yellow. It's orange. See?
Orange,
Like,
yellow?
see this? Orange.
No, just type orange.
So orange, everybody. Put it against white paper, it shows up better. Okay, then the other one I have iodine and NaBr. And what color is the top layer?
Pinky purple.
Purple again. Okay, so that was purple over there. Now you guys are filling this in. If you weren't here last class, be sure you get this filled in. Okay, last 2, I got sodium iodide and chlorine. I shake it all up and you can see it is purple. Definitely purple on top. And the last one, it almost looks black on top, but it's not. So if I shake it, see what happens to the sides of the test tube. It's very definitely purple, isn't it? Okay, purple is characteristic of iodine. Everybody got that? Okay. So those are our, those are the lab we did that last was purple also. Okay, now if you look at that data table over there on the wall, which boxes, don't sit down yet, which boxes actually represent a chemical reaction?
The first one and the second one.
Okay, point to one you think might represent a chemical reaction. Those two?
Yeah.
Okay, those two, I'll be right, they do. On the far right-hand column, do any of those three purples on the far right side, do they represent a chemical reaction?
Mm-mm.
No, because it started purple and ended as purple. So really, how many chemical reactions were there on this data table?
3.
3. Good job.
Oh.
There are 3 of them.
Yeah.
Okay, and we're going to look at what those reactions were right here. We'll look over here at this board. We know that since we started with chlorine being green and the NABR ended up as orange, see this was orange, we know that this bromine was replaced because bromine is orange. We all following that? This is really important you understand this is your first chemical reaction, so be sure you're focusing. Okay, so we know that the chlorine came in and pushed this bromine out. You understand what I mean by that? How do we know it was pushed out? Because my layer turned orange, which is what bromine is supposed to look like. So when the layer turns this color, you know you got bromine in there. Okay, the next two, chlorine came in and pushed out the iodine. We know that because the top layer turned purple. So we know the iodine got pushed out. Now iodine in its elemental state in water doesn't look purple. This is what it looked like. But if you swish this around and look at it from the side, sometimes you can see a little purple glint there. And you might have noticed that your dropper, the plastic dropper the other day, slowly became more purple as we did the lab. So that's a kind of a weird thing. Iodine absorbs into that dropper. Okay, so the chlorine pushed out the iodine, the bromine pushed out the iodine. Now, which one of the chemicals that we had, chlorine, bromine, or iodine, replaced the most? Which was the most pushy?
Chlorine.
The chlorine was, because the chlorine replaced both the bromine and the iodine. Now look over here at the periodic table. Here's chlorine, here's bromine, here's iodine. Was it the big one or the small one that was the most pushy? We just said chlorine pushed out more stuff, didn't it? So the question is chlorine bigger or smaller than iodine in terms of atomic size? Remember our graphing we did with atomic radius? This chlorine is smaller. So the big learning thing from this lab is that the smaller atoms push out the bigger ones when we're talking about nonmetals. So smaller nonmetals are more active than big nonmetals. That's not true for metals. When we looked at the video last week with the glass dish and the cesium, it was the cesium that made the glass dish explode. Notice it's big. All right, so for metals, activity increases when they're huge. For non-metal, activity increases when they're very small. So the most active non-metals, most active metals, down here. And the exception to that, of course, is the noble gases. They're not active at all because they've got full outer energy levels. You can't put any more electrons in. All right, let's cut the video there.